Today we're going to do a projectile that's being fired straight up in the air and try to figure out what maximum height it will reach. One of the intimidating things about free fall is that, again, we can find everything from one piece of data. And I know that you know from previous examples that we need to have 4 variables, including our unknown. And so when they just give us one, it can be quite intimidating. All right, let's start with this sketch. So we have a little rocket, and we're going to send that guy up. And it's going to go up, and it's going to come back down. Okay? And we want to know what its maximum height's going to be. Okay? So let's start by listing data with symbol and unit, and the recommendation is we're going to fill out our little data table. So we have VI, VF, D, A, and T. Let's see which of these that we can figure out. So they said it takes 8 seconds to return to the time. Now, one of the things to the ground, one of the things that makes these problems difficult is the fact that we have it's going up and coming back down, and you have to distinguish between total time and just time up to the top. So this is total time is 8 seconds. Okay. Now, what else do we know about this problem? Well, it's in free fall, which means that the acceleration due to gravity is 9.81 meters per second squared. Now keep in mind, little g refers specifically to acceleration due to gravity, but in a formula, because it's an acceleration, we're going to use, it's going to be represented by the letter A. All right. So we know this within 17 miles or kilometers of the Earth's surface, things fall at 9.8 meters per second squared. The Regents likes to use 9.81. So we're going to put this in, and because up is the positive direction and gravity pulls down, this has got to be a negative number. So that's one of the things you got to write. Even though it's going up, the acceleration is negative because it's always causing that negative change in velocity. All right. D is what we're looking for. That is our unknown. All right. And we don't know VI, but we do know the velocity somewhere. Whenever something is tossed up and it changes from a positive direction to a negative direction, it has to stop at least for a second. And we could see this back in graphing, right? If we graphed velocity over time, okay, it's going to start with a high velocity in the positive direction, and right there it stops and turns around. And when it does that, the velocity has to be 0, at least for an instant. Okay, so the velocity is VF at the top, and in the video they talked about doing the top. Okay. Now, so this is all our data, and at this point you can see once you put in the hidden pieces of data, we actually do have 4 variables. We have our 3 pieces of information that we know and our unknown. So now we can pick a formula. Okay, so you want a formula that has all of these things and nothing else. Okay, so something that has VF, D, A, and T, and there is nothing. So there is a trick that we need to use, right? Now, a couple things about this. The trip up in free fall is symmetrical to the trip down. Whatever happens on the way up gets undone on the way down. That means a couple of other things. It means that time up equals time down. All right, it's a symmetrical trip. Other things, whatever the initial velocity is here will be the same size or magnitude as the velocity here. All right. It's a very symmetrical trip. And what that means is that we can make this up here, the top, the initial, and down here, the final. You decide when the initial and the final are. All right. So since this is V0s at the top, I'm actually going to make this an initial velocity. Okay. And let's say I'm just going to kind of like make this go away. All right, so the VI is 0 at the top, and we're just going to look at the trip down. It's just as legit to look at the trip down as it is to look at the trip up. All right, and then if we realize we're just looking at the trip down, this becomes 0, and now we actually can pick a formula. Not from here, from here. All right, so if you look at this one, we've got D, VI, and T. Okay, so this is our formula. All right, so we'll just move this down a little bit. All right, and let's see. D equals VIT plus 1/2 AT squared. Now, the other important thing is that on the trip down, it's only going to use half of this 4 seconds. All right, so again, this becomes something we're not going to actually use in the formula. All right, now in this, since VI is 0 and 0 times anything is 0, this whole term drops out, and you get what's called a working formula. D equals 1/2 AT squared. Now, when I'm going over problems, I'm always going to start with the reference tables, but realize that on a quiz or a test, you can have something from the reference tables or a working formula, or you could even rearrange this, and that's another form of working formula. Now we're going to substitute in with units. Okay. All right. So let's see. This is getting lowered instead of. Excuse my technical difficulties here. On these days, I spend far too much time aligning everything, trying to make it look pretty, and it just doesn't really work. Okay, I need to just get this up. Okay, so now we're going to sub in with units. So D equals 1/2 times negative 9.81 meters per second squared, and the time is 4 seconds. Don't forget to square that. Now, when you're doing your algebra, you need to square the 4 seconds first. I'm going to drop units. So I'm going to say D equals 1/2 times negative 9.81 times 4 squared is 16. And then when I plug that into my calculator, okay, 9.81 times 16. I get 78.4. Actually, that rounds to 5. And the unit is meters. Now, here's the thing. Why is it negative? Well, it's negative because it's actually got a negative displacement. On the trip down, it's going in the negative direction, so expect this to be negative. But they didn't ask where did it go. They asked what the height is. So the height, actually, the final answer for the height is going to be 78.5 meters. And done.